All right, so we're talking about graphs of rational functions today. Really what we're going to do is kind of graph what we've been working on all week long. The most simple rational function is this f of x equals 1 over x. And really if we were going to do ordered pairs on it, just like we did on the bell work, we could just throw some ordered pairs into our t-table on the x side and then just figure out what they are on the f of x side. So if you put -3 in, you'd have a -1/3. If you put -2 in, you'd have a -1/2. You put -1 in, you get a -1 back out because you're just substituting it in right here in place of the x. If you put 0 in, you get an undefined answer because you can't divide by 0 in a fraction. 1 divided by 1 would be 1, 1 divided by 2 would be 1/2, and 1 divided by 3 would be 1/3. Then it's just a matter of plugging in those ordered pairs. And just a minute ago when I asked you guys what actually happens here, you guys said that would be a line that we would approach and not cross because you can't actually be equal to 0. So you know right here at 0, you're going to have a line that you're going to approach and not cross. So then just kind of graph your ordered pairs. You're over -3 and down 1/3. Just do your best guess on how far down that is. You're over -2 and down 1/2. Then you're over -1 and down 1. You're over 1 up 1, over 2 up 1/2, and over 3 up 1/3. And then we just said that these two graphs would look like this. They have these lines that they're approaching and never crossing, and we call those lines asymptotes. Okay. The shape of this graph is called reciprocal. And if it consists two symmetrical parts, then it's called a hyperbola. Hyperbola. Hyperbole is from language arts. Hyperbola is mathematics. Okay. What? I don't know, they just like to. It's math. It's supposed to be confusing. All right, so a little bit more about this function. Let's do some things on it that we already know how to do. So asymptotes, can you tell me the lines that you can see this approaches and it never crosses? We just found when we graphed it that we had this one right here, but you see another one? Yeah, the x-axis also. So the original parent function of a reciprocal function has two asymptotes. It has the asymptote at x equals 0, and it also has the asymptote at y equals 0. X equals 0 would actually be the y-axis, and y equals 0 would actually be the x-axis. So for graphing the original function, we know that we have asymptotes at both of those places. Now, just like we've done with other graphs, we could get that asymptote to move left or right and the other asymptote to move up or down by changing the numbers that are attached to our x or attached back behind our function, just like we always have done. And we're going to do that in just a minute. All right, so help me with my domain on this. Where's my domain going? How far to the left? Because these are going forever, right? So I would have -infinity, but I'm going to stop at 0. Then I'm going to start back up at 0 and go to infinity. So on these functions, you have that two parts to your domain, and you're going to have two parts to your range also because of that asymptote that you cannot touch or cross. So if you talk about how low your graph goes to how high it goes, it's 2 starts at -infinity and comes up to 0, and then starts again at 0 and goes up to +infinity. Okay. Anybody remember what the interval of increase is? It's where you have positive slope, right? And then you have an interval of decrease where you have negative slope. So we would mark positive or negative slopes here. What kind of a slope does this line have?
Special slope.
It's a special slope. Okay, think about how would you get from this point to this point. You go down and over, down and over, down and over, down and over, down and over. So is this positive or negative slope?
Negative.
It's negative slope. I agree with you on that. Okay. What about this one? How do you get from here to here?
Positive.
You always have to run to the right. And so it's negative. It's down and right, down and right, down and right. So this is also a negative slope. Do you guys agree with me on that? Because interval of increase and interval of decrease talks about the slope. Both slopes are negative there. Neither of them are going in the positive direction. Even though they're curved different, aren't they? But they're both still negative slopes because you go down and to the right. So your interval of increase, there wouldn't be one. And your interval of decrease would be from negative infinity to 0. And then again from 0 to infinity, because remember how we use our x-axis to write our intervals of increase and decrease. All right, what about x-intercepts? Does it ever cross the x-axis?
No.
Nope, it's not going to. How about y-intercepts? None, because it doesn't ever cross the y-axis either. Okay. Questions on that? All right, this next little slide right here is just showing you all of the graphs you already know how to graph. You know how to do an absolute value graph. We can get it to move left or right by changing this number here. We can get it to move up or down by changing this number here. And we can change our pattern by changing this number here. Everybody agrees with me? We already know how to do that, right? This is the squared one. We can move it left or right. We can move it up or down. We can change the pattern. This is the cubed, the square root, the cube root, and the same thing happens. We can get it to move left or right or up or down, left or right or up or down, change the pattern, right? We know how to do that by looking at the graph. So guess what happens here? This is our new graph. What do you think the h is going to do to it? What did the h do on all the other ones? It moved me left or right. And what does the k do? Up or down.
What about the A?
What does the a do you think? What did the a do up here? It changed your pattern. It's going to change the steepness of your graph just like it did on all of our other graphs, okay? So thinking about what we just said about left or right or up or down here, let's see if we can graph this one kind of just by sketching it and not really as much by finding exact ordered pairs. So when you look at this right here, what do you think the -2 is going to do to the graph? Now, before I always told you if it was in grouping symbols to do the opposite, right? That's what I told you, and that was a good rule of thumb. But think about this for just a minute. If I put a +2 in right here, what happens to the bottom? It changes to 0, right? And can you have 0 on the bottom of the fraction? No. So what's the important number right here? +2, right? +2 makes me have an undefined bottom. So guess what I just found out where my asymptote was? It's at +2. So if it's minus, it's going to move us to the right. Mostly because, and this is the way I like to think about it, I'm looking for the number that can't be on the bottom. The number that makes the 0 bottom. And the number that makes the 0 bottom is +2. Okay? Guess what happens with the +3? We're moving up 3. So, right 2, up 3. Guess what I found at that up 3 spot right there? My other asymptote. Yep. And so I'm right here. And then if I just follow the pattern, because we're sketching here, we're not going to be super exact. I mean, I could substitute values in to be exact. But I know I have a graph coming like this. And I know I have a graph coming down like this. Okay. Did you see how we just used the parent function in order to move it around to graph a new function? So this works the same way as all of our other graphs have worked. We can... you know what? When I ask you to be specific, I'll be sure to ask you to be specific. Okay, about exact points. Okay. So on this next one right here, It says graph the function of y equals x, or 4 over x. If we can focus that, we can see it. Okay. It says draw the asymptote x equals, does anybody know what number makes this bottom a problem? Is 0, right? So we know we have an asymptote at x equals 0, which is the y-axis. Do you guys agree with me on that? So we have an asymptote here. Then we're wondering where our asymptote is going to be at y equals. So think about it for just a minute. Did I move left or right, or did I move up or down to change my other asymptote? Nope. So where is it going to be at? Yeah, it's going to be at 0 here also. Okay. So I know that I have my two asymptotes there. Then it says point plots to the left and points right. Plots. Someone say that for me. Point plots, plot points. Woo, that's bad. Anyways, plug in your values and find out your values, right? If you put -2 in, you'd have 4 over -2, which is -2, right? So you'd have that ordered pair -2, 2. -2, -2, I should say. When you put -1 in, you'd have 4 divided by -1, which is a -4. So -1, -4. When I put 1 in, I'd get 4 out. And when I put 2 in, I get 2 out. Does it give you a pretty good idea where your graph's going? Yeah, so what did that 4 on top do to my graph? Anybody describe to me what the 4 on top did? Okay. Anybody else want to describe it in another way? I like to notice how far it is from the origin now. Did it move further away from the origin than it did the first time? I think it did for sure. So anyways, and in the words down here it says draw the branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. So again, after you get a couple of points, we're just going to sketch those branches of the hyperbola. They call these branches, both sides of it. Okay. That's not too bad though, right? Like we could figure out where things were. We plugged in a couple of ordered pairs and we were good to go. Okay, the same thing on this one right here, but this time we have some left or right movement so we can figure out what we're doing there. Does anybody know what my asymptote is going to be from looking at the bottom right there? -3. It's a -3 because it has to make the bottom 0. So I know I'm at -3. X equals -3 is an asymptote. So I'm right there with an asymptote. And then, do you think that my y1 moved at all? Yeah or no? Up 2, didn't it? You see the up 2 movement going on there? So I actually moved up 2 for my asymptote, so I'm right here. Okay, which would be at y equals 2. Now we're just going to plot some points to figure out where we're going. Do you see maybe where they picked their points at? Do you see that they made sure that they were in different quadrants? Can anybody tell me how we could get our graph to flip into the 2 other quadrants? Throw a negative out in front, right? Instead of being up here and up here, guess where it would be? Over here and down here. So did we throw a negative out in front? Oh, so guess what's going to happen this time? We're going to be in different quadrants of our asymptotes, right? So when you put -6 in, you would have on the bottom -6 plus 3, so a -3. So -6 divided by -3 is a +2. +2 plus 2 is 4. So when you're over at -6, 3, 4, 5, 6, 1, 2, 3, 4, you're up at 4. When you put -4 in, on the bottom, -4 plus 3 is -1. -6 divided by -1 is 6. 6 plus 2 is 8. So when you're over at -4, you're up at 8, which is clear off the graph. Gives you a good idea where you're coming over here. This other one will be a mirror image of that over the asymptotes. But if you put -2 in, you'd have -2 plus 3 on the bottom, which is 1. -6 divided by 1, which is -6. And -6 plus 2 is -4. So you're over at -2 and down 4. And really, once you find those ordered pairs, you can just sketch your graph. I'm not even going to take the time to do the second one. Which one, what? Oh, I counted wrong, didn't I? Jesse's right. You notice that these are counting by 2s. So I counted by 1s. So I'm just going to go change those to 1s, seems that's what I did. Thanks for pointing that out, Jesse. Sorry about that, you guys. All right, so the domain of my graph, how far left to how far right am I going? I'm starting at -infinity, but I'm stopping at where? -3. Then I start back up at -3 and I go to infinity. What about my range? I start at -infinity, but I stop at 2. Then I start back up at 2 and I go to infinity. Okay? Questions on how we graph that? Is this hard or just different?
It's a little irritating.
A little irritating. I'll go with irritating. Okay. All right, this is a vocabulary sheet. It talks about different things that are going to happen. One of the things that we need to talk about is called discontinuity. And that's a point in which the graph of a function is not connected. We call those discontinuities. And really this happens because we can't divide by 0. Okay? We either call those points of discontinuity holes because there's a hole in the graph, or we call them asymptotes, vertical asymptotes to be exact. Okay? So holes happen when do you remember the other day when we were canceling stuff on the top with stuff on the bottom? When we were solving our multiply problems and our divide problems and our add and subtract problems. Well, if you find two things that cancel, one that's on the top and one that's on the bottom, at that value, you just found a hole in your graph. Okay, so we're going to be looking to see what cancels to see if we have holes in our graph. We're going to be looking to see what the bottoms factor to be to see where we have vertical asymptotes at, because that's where the bottoms can't equal to 0. Your x-intercepts come from when y is equal to 0, and then the horizontal asymptote, and that gives you some rules here about the horizontal asymptote. Those are just the lines that your graph approaches and doesn't cross. All right, so let's look at this next one and decide what's different about this one than the other ones that we've been doing. Anybody tell me? Yeah. There's 2 x's on the bottom, which is not good, right? But if we look at that in factored form, it's going to be better. Okay? So find me my 2 numbers that will multiply to a -12 and add to a -1. -4 and +3. So I have 2 special parts of this graph right here. Did any of these cancel with the top? No, so they were not holes in my graph. They're asymptotes. Okay, so I have an asymptote here at x equals 4, and I have one at x equals -3. Do you see how they graphed them there at 4? And they graphed it at -3. Now this is kind of a funky graph. Once you start getting more than one thing on the bottom, you're going to have usually 3 parts to your graph. You could get up to 5 parts. You can go 7. You could have, like, you know, as many parts as you want going on there, okay? So the holes come from cancellations. Did we have anything cancel? No, we don't have any holes. Okay. Do we have vertical asymptotes though? We have 2 of them. We have an asymptote at x equals 4 and one again at x equals -3. So on your worksheet, when we get to it tomorrow, it's going to ask you how many discontinuities you have. Your discontinuities come from the bottom of the fraction. We have 2 discontinuities and they're at x equals 4 and x equals -3. The discontinuities are just where the bottom of the fraction can't be equal to 0, so those are our problem spots, okay? Then it says to find the x-intercept. In order to find the x-intercept, all we have to do is set the numerator equal to 0, okay? In this case, do you guys see that if the numerator was set equal to 0, it would just be at 0, right? Because there's nothing up there for variable-wise in order to solve for that. So the x-intercept of this graph would be at x equals 0. And then the horizontal asymptotes, because we didn't move left or right or up or down, it is at y equals 0. On that cheat sheet that I just gave you, there's this part right here that tells you about the asymptotes, how you tell your horizontal and vertical asymptotes. But if you went and read this right here, it tells you to look at the degree. It says if you have a different degree, meaning the denominator is higher, is the denominator the top or the bottom of the fraction? The bottom. So if the bottom of the fraction has a higher power, your asymptote will always be at y equals 0. Okay? If you have the same power on the top as you do on the bottom, then you're going to use those leading coefficients to find your asymptote. Same power, it's going to be at 4/7. Okay? So that cheat sheet will help you find where your asymptotes are at when you're confused about where they are. Okay? All right, this next one. The very first thing we're going to do in order to graph this is we are going to factor the top and the bottom because I need to know where things will cancel at. So on the top, what does x squared minus 9 factor to be? Yep, x plus 3 and x minus 3. And on the bottom?
X plus 2 and 2 minus 2.
Yep. So did that do me any good to factor that? No, because nothing cancels, right? How many discontinuities do I have? Okay, I only have 2 because I only look at the denominator, okay? But that was a really good guess. So discontinuities come from where the bottom would equal 0, so I have 2 of them. And what are their values going to be? They're going to be x equals -2 from this one, and x equals +2 from this one. Were either of those wholes? Nope, because they didn't cancel on the top, so no holes. So are they asymptotes then? They are. If they're not holes, they're automatically asymptotes. So I have an asymptote at x equals -2, and I have an asymptote at x equals +2. So one here and one there. Okay. Then it says find the x-intercepts. Does anybody remember how to find the x-intercepts? We get to set the top equal to 0. Okay, so if I set the top equal to 0, I would have x plus 3 equals 0, and I would have x minus 3 equals 0. And I can solve both of those in order to get my solutions. Where is x going to be equal to 0 here? -3. And where's it going to be equal to 0 here? +3. So my x-intercepts are at 3 and -3, which means my graph is crossing here. Oh, go x-axis, people. Here, is that 3? Did I go not far enough on this one, huh? I did not. This is 3 right here and -3 right here. Sorry about that. Like I said, I should have copied these bigger because they're really hard to read. I just drew my asymptote in the wrong spot after I told you where it was at. It shouldn't have been right there.
This is a perfect example of why you should use
Pencil. Use pencil. Okay.
Do you have a 100% chance of screwing up that?
Then we're going to find our horizontal asymptote. The horizontal asymptote comes from, anybody remember what I just told you about the powers? If the powers are the same, what do? You use their leading coefficients, right? The number out in front here is 1. The number out in front here is 1. So 1 over 1 is 1. So my asymptote is at y equals 1. So up here. Okay. So, just to sketch this really quick, you know you have a curve down here that approaches this line and approaches this line. It will not cross those lines, right? You know you have a curve here doing the same thing. The big question of the day is my curve up here? Is it down here? Or where's it at? Because anytime I divide my graph into spots like that, I'm definitely going to have part of a graph there somewhere. So how could I tell if I'm up here or up here? Could I substitute a number in? Would it be easy to substitute in 0? Yeah? Do you want to do it in the original, or do you want to do it up here in these parts? Nobody cares? Alright, if I put 0 in, I'd have 0 plus 3, which is 3, times 0 minus 3, which is negative 3. I'd have 0 plus 2, which is 2, and 0 minus 2, which is negative 2. Those would be multiplied together. So on the top, I'd have a negative 6. On the bottom,